Okay, so again, this is our formula. So what we're going to do now is we're going to do an example with it. So before we get to that, let me just point this out. You might be wondering, okay, well, when do we actually use that formula? Well, basically, if you have many deposits. I mean, in this class, what we're assuming is that monthly deposits are made on a regular schedule and with the same amount. What's happening again is you're letting the money sit there and earn interest. So for annuities, if we have many deposits. With compound interest from the previous chapter, we made one deposit and then let the account do what it does, compound and earn interest. Okay, now let's get to an example. So this is actually a special kind of retirement account. What happens here is the money in there does earn interest, and it's exempt from paying from taxes. In other words, you don't pay taxes on that money. The thing is, though, you can't take money out of there until you reach a certain age. I mean, I think if you try taking money out of there, there's like a big penalty or something like that, mostly because to recover taxes, I guess. I mean, you could form an annuity, I guess, with a savings account. You make monthly deposits and all that, except, though, you may have to pay taxes on the interest, on the interest earned. With an IRA, that doesn't happen. Anyway, here, okay, we're going to assume someone named Mary is depositing $100 each month, okay, into an IRA, and it has an APR of 9%. In other words, the account is earning 9% interest. We want to know how much she's going to have in that account in 20 years. Okay, now notice though we didn't state the the compounding frequency. We didn't state that. Okay, but again, based in this chapter, we're assuming it's the same frequency as how often you make deposits. It's the same frequency as the number of deposits there are. So in this case, it's going to be monthly since we're making monthly deposits. All right, so in this case, we know our monthly payment is $100, right? That's what PMT is, $100. R is 0.09, okay, 0.09, because again, that's the interest rate as a decimal. N is 12, okay, N is 12. Good. Again, that's how many compounding periods there are. In a year, we're making monthly deposits, so we're assuming it's being compounded 12 times a year. It's going on for 20 years, so T is 20. And the balance is what we're looking for. That's what capital A is. That's what we're looking for. We have our formula. So now we got to calculate A. So this is the calculation, okay? So again, I plugged in the parameters into the formula. That's how we got the top line here. And now you could do this in the, in your calculator if you want. You could. Basically what I would do is handle the top and bottom, the numerator and denominator separately. Just you got to remember your order of operations. In here, in the, in the parentheses, we have 1 plus 0.09 over 12. I would do that first. And whatever you get, raise that to the exponent. The exponent you calculate is 240. Okay? Like so. Good. And then, you would subtract, multiply, and all that stuff. The parameters are still here. That's what I've added. And doing so, if you do this right, you would end up with this amount. So she'll have $66,788.69. Okay, good. You know, at the end of 20 years. You could do this calculation in Excel or Google Sheets. I did that. It's really not hard to do. The formula is not programmed in there. At least I didn't see it. But you could do, for instance, the numerator as one cell, the denominator is another one. You know, if you need help with that, don't be afraid to ask me. But again, you could do it in your calculator also. Now, what's going to happen is the amount that's going to be in there in the end, you know, this amount, it's going to come from monthly deposits. But as we saw in the previous example, in the first example with the table, excuse me, as we saw there, it's also going to come from interest, right? So this is going to have the monthly deposits along with the interest. How do you get the interest? Well, this is the total. We're subtracting the monthly deposits, the number she makes, right? They're each $100, 240 of them, because it's 20 years, 12 months per year. And we end up with this. So she ends up with, so this is the amount of interest she's getting. Remember, she's not making withdrawals, she's only making deposits. Okay. You know, just something I wanted to point out. So that's our first example. Now, the calculation's not terrible. It turns out there is something called a Tvm Solver that you can use to solve this. I mean, the link is on Blackboard. It's also here. Actually, let me see if I can highlight it. No, I can't. Oh, wait. Nope, sorry. There we go. Took an extra step. Let me just copy this. I'm going to post it in the chat. Nope, I'm not going to. Okay. You know, that's basically a link to the Tvm Solver. Before I take you there, actually, it's actually made in Geo by someone. I didn't make it. I'm just grateful it's there. Because I also do know that in the TI-83s, okay, in the TI-83 calculators, there is an app there. Okay? For the Tvm Solver, there's an app there. The book goes into how to use it. Okay, the book goes into how to use it. So, you know, I would read that if you can. All right, you know, when you can, I mean. If you have a TI-83 calculator or later. All right, so anyway, before I get to the Tvm Solver, let me just present this notation because the Tvm Solver uses it. You have capital N. That's basically little n times t. So it's the number of compounding periods a year times the number of years. Capital I, that's your APR, but you have to write it as a percent. I know we're normally used to writing it as a decimal, but it's going to be written as a percent. PV is how much is in the account now, you know, at the present time. PMT is your monthly payments. Your monthly payments, again, we're assuming they're regular payments, monthly payments. Good. FV is the future value. That's how much will be in the account later on, you know, after time has passed. And these two here, this is payments per year, compounding periods per year, and of course these are the same. Well, actually, I shouldn't say of course they're the same, but in this class they will be. They don't usually have to be the same, but in this class they will be. Okay, before I get to this stuff, let me just show you the Tvm Solver. I have to stop sharing this though, because unfortunately I can't share two things at once, which is really annoying. So here's our Tvm Solver. You can see, you know, you have n, right? That's what I said before. That's little n times t. I percent, that's the annual interest rate. You don't write the percent sign, but you write it as a percent. You don't convert it to, you don't move the decimal to the left 2 spaces. PV, right, what I said before, that's the amount in the account now, and so on. I mean, what's nice about this is if you put everything else in there, you can calculate the unknown by just clicking on the buttons, the white buttons on the right. Right? You know, you click on the buttons here, essentially. See? Okay. All right. Now, what's really annoying about this TVM thing is that sometimes answers could be negative. That's not terrible. You just have to know how to interpret it. If you have a positive value, that means money is coming into you. I think it's called the cash outflow, if I remember correctly. Where's my notes? That's what we call a cash in outflow if it's negative. So I was right. If you have a negative answer, then you have a cash outflow. Okay. Good. That's what a cash outflow is. A cash inflow, okay? Cash inflow, that's when, you know, money's coming into you, money you're earning, money going into your pocket, so to say, if that makes any sense. That's positive, though. And outflow, even if you're putting it into an account, like a retirement account, that's going to be negative. So deposits are negative when you use the Tvm solver. But cash inflows, you know, that's positive. So, I mean, generally, if you're using the formulas, you don't have to worry about negative and positive. Even if you get a negative answer from TVM, you know, I don't think you include the negative sign when you put your answer down. So, but it's just something to consider. All right, so let me stop the recording.